Welcome to the introductory video about capacitors. We're going to look at what is a capacitor and why would we even want to use one. You can see the sections highlighted here that you'll read as follow-up, and we'll do some interactives in class. So quite simply, a capacitor is a device to separate charge. And by separating charge, energy is stored because an electric field is created, and to move those charges or separate them, work has to be done. So if we look at a couple examples of this, we have a capacitor here. It is hooked up to a battery, and what happens when we turn it on is you can see the electrons, which are free to move, all migrate, are pushed by the potential difference of the battery over to one side, creating a positive plate and a negative plate. It's very important that these two plates be separated so that they are insulated from each other. And you can see that establishment of that electric field in between there. Electric field wise, what's going on is here are two plates again. You have a very uniform electric field in the center. You have some curling here, which is called edge condition. And you may have created one of these in lab. You may have also done the equipotential lines in there. This was one of the options in lab, but when you get those charges separated like they are here, you've created this electric field, and you have stored energy by separating those charges. Another thing to look at here, what is capacitance? Well, capacitance is a description of the physical arrangement that is related to how much charge can be separated by how much potential difference, and therefore how much energy is stored. So you can see here we've got some graphics to show you what capacitance, what plate charge, and what stored energy are involved in the situation here. So I've got a plate area right now of 100 millimeters squared and a separation of 10 millimeters. You can see I have a very low amount of capacitance here shown on this bar graph, or the thermometer here. If I increase the plate area, notice this is what's called a parallel plate capacitor. As I increase the plate area, my capacitance increases. More charges have the ability to be separated and stored. A greater electric field can be created. If I bring these two together, notice my capacitance also goes up. The closer they are together, the higher my capacitance is. The larger the plates are, the larger my capacitance. So we can also show in here we're going to show electric field lines. So as I start, I'm going to make these really small again and really far apart, and I start to apply a voltage. You can see I start to separate charge, and I'm storing energy, and I'm creating an electric field in there. Notice those field lines going from positive to negative. And as I increase that amount of voltage, that amount of potential difference, just like I was doing over here, I applied a potential difference. This simulation shows it right away. I get a greater separation of charge, the greater the potential difference, and I get a greater amount of stored energy. If I increase the plate area, I'm going to increase my capacitance, increase the amount of charge that can be separated. Notice the charges are still separated the same amount, but there's a greater area. That's the separation they're spacing on here is due to the voltage applied. Notice that less voltage means more separation because they don't want to be next to each other. And then as I bring those closer together, notice my plate charge goes right off the scale even, and my stored energy gets really high. And then as I separate them out, my plate charge goes way down again. Alright, so, but now how do we keep these apart? Right now we've got a vacuum or air in there, a vacuum likely. if we use a substance called a dielectric, which is an insulator placed in the field, and we can reset it. We'll do it back here first. Okay, I'm going to reset with a dielectric. I have a dielectric, it's insulating. As these charges move, as they're forced to go, that dielectric polarizes, and so changes the electric field, therefore changing the capacitance, changing the amount of energy stored and the amount of charge that can be separated across the two. Alright, so that dielectric is changing the electric field. If I'm here, alright, and I've got my electric field, I bring my dielectric in, and look, it changes the capacitance. Why is it changing it? Well, if I apply that field, if I apply that potential difference, you can see it is actually changing the field, because look at how many more charges are going in there. That is more charges that can be separated on the same potential difference. Hence, your capacitance, your plate charge, and your stored energy goes up and up and up. I wanted to show you a short video here about charging and discharging a capacitor. So when we started off here, we're going to have an animation of a capacitor that's hooked into a circuit with a battery, and then also with a load. So here you can notice that the charges are moving off the battery, and that causes, when they move off the battery, that causes the charges to separate, and the charges that were at home on the capacitor to move off the capacitor. As you can see, they move the blue sleeve. So charge comes from the battery, creates a potential difference, and charge flows off the capacitor. Remember, the red and yellow here are not attached to each other. What's happened is the red is, and we'll see in a minute, the red and the yellow have become polarized. Now energy is stored there, and you can discharge that quickly through a load like a bulb. And now the charges are flowing back where they want to be. They're giving up the energy. So here's, as these red and yellow parts get polarized, as electrons move off of one and onto the other, and then they go back to where they want to, giving up that energy through a bulb. If you've ever used the flash on a camera, or like a disposable camera or a phone, this is how it was powered. You power it up, that's the winding you hear, you power up the capacitor, and then it discharges through the bulb. Alright, one last thing before we move on. I wanted to show you the equations here. C stands for capacitance. U is for energy stored. Q, of course, is charge. A is area. D is distance between the plates. And so we have, this is our equations here. We can calculate the energy stored in capacitors, in a capacitor. We can we can calculate the capacitance of it. Notice the capacitance is here based on the physical characteristics, and here it talks about, because it has this capacitance, this much charge can be separated for this amount of potential difference. Alright, and you also have some things about how the capacitance changes if you add that dielectric, that K in here. Alright, I will see you in class.